that are quite a bit more difficult. All right, so the first one that I have selected for us to do today is the one in the center of the screen. 1 plus cos 2a over cos 2a equals tan 2a over a. Now, your teachers at school may have told you that we can work with both the left and the right hand side, but we have to work with the left hand side and the right hand side independently. This is not like solving equations, so you cannot move terms from one side of the equal sign to the other. That's not allowed, because you have to prove that the left hand side equals the right hand side. But what you can do in some instances is work with the left hand side and simplify it as much as possible, and then do the same thing with the right hand side. Work with that independently and simplify it as much as possible. And if it equals the same thing, then you've proved that left hand side equals right hand side. Sometimes it's necessary for us to do that. Okay, the other thing that I want to talk about a little bit today, it's not really going to apply in this example here, but in some of the other ones that I'm going to use, is what a lot of grade 12 struggle with is knowing which double angle identity to use for cosine. And that really depends on what cos 2a comes with. So we're going to make some notes on that, and we're going to talk about it just now. Perhaps what would have been a good idea, sorry, I always do this because I know the identities, but I shouldn't work that way. Let me just grab these, I beg your pardon, and slap them over here as well. So those are there for us. Sorry, they're a little bit smaller. Maybe we can make them a little bit bigger. But now it really does matter what we choose to combine, or which identity we choose to use for our cosine double angle. Okay, not every single possibility is going to work in all situations. So there will be some situations where one will work and the other two won't, or whatever the case is. But we're going to have a look at that in a little bit more detail. All right, so as far as this question on the screen is concerned, our starting point is to work with the left-hand side. Okay, so we come along and we say the left-hand side is equal to 1 plus cos 2a. So given our options, what do you think is the best thing for us to combine 1 plus cos 2a with? Any suggestions? What do you think we should combine it with? Do you think we want to try and get rid of the 1? Do we want to keep the 1? What do you guys think? Get rid of the 1. Absolutely, Kanyisile. So if possible, try and get rid of the 1. Okay, so if there's a plus 1, then 2 cos squared a minus 1 will get rid of the 1. And if there's a negative 1, then 1 minus 2 sine squared a would get rid of that. Okay, so in this particular case, we are going to go with option number 2. All right, and we are going to write 1 plus 2 cos squared a minus 1 over cos 2a. Now here, I'm just going to write this as cos 2a for now. Right, and we can talk about what we're going to do with it in a second. Right, at the top, we've now got 2 cos squared a, and at the bottom, what do you think we should do with cos 2a now that we can see what we've got at the top? Do you think it matters? I mean, if I did this, if I went 2 cos squared a minus 1, change it to sine. Okay, if I changed it to 1 minus 2 sine squared a, then I've still got this problem, can you see here, where I've got 2 terms at the bottom and only 1 term at the top, right? And I'm not allowed to cancel over plus and minus signs. So I'm kind of stuck here. I don't really know where I'm supposed to go next with this. There's no sort of obvious route. So this is one of those sort of situations where maybe we should go and work with the right-hand side and see what happens. Okay, how would we write tan 2a? Sine over cos, absolutely. So that would give us sine 2a over cos 2a divided by sine a over cos a, because that's what tan a is equal to. Sure. So there's only one thing that we can do here, which is to tip in times. But even then, that's not going to help us. Well, we can tip in times, but we can't cancel anything out. So why don't we write sine 2a as 2 sine a cos a? We don't know what to write cos 2a as, so I'll just leave it as cos 2a for now, times, and then I've got to put cos a at the top, and I need to put sine a down at the bottom. If I wanted to, is it okay for me to cancel like that? Is that allowed? Am I breaking any rules? No, I'm not breaking any rules. I'm allowed to do that. So at the top, I'm now going to end up with 2 cos squared a. Okay, so 2 cos squared a, I've got the same thing at the top of it as 2 cos squared a. And here at the bottom, I've got cos 2a. Right, so I could have left that as cos 2a as well, or I can write it as 2 cos squared a minus 1. And now here you can see what I've simplified the left-hand side to, what I've simplified the right-hand side to. It's the same thing. So therefore, the left-hand side equals the right-hand side, and the identity is proved. Okay, so just be aware that sometimes you may need to work with both sides and not just one. Why is it cos squared a? Cassandra, that's your identity. Cos 2a is 2 cos squared a minus 1. Or are you talking about why is the numerator 2 cos squared a? Cassandra, do you mean numerator or denominator? Oh, why is it the numerator, I think you mean. Okay, so remember, how do we multiply fractions, Cassandra? We multiply tops with tops and bottoms with bottoms, isn't it? So 2 times cos a is 2 cos squared a. Okay, just like 2 times x would be 2x squared. Am I answering your question sufficiently, Cassandra? Oh, okay, cool. All right, yeah. So remember, working with trig, you've got to be able to work with fractions. You've got to be able to multiply, divide, add, and subtract. Super, super, super important. Okay, so now that I have gone on for a little while about that one, I would like you guys to try this one. Okay, so this is supposed to be a 2 over here, and I will go and grab this is a 2. And I will go and grab the identities and bring them down for you. Okay. So now I'd like you guys to try this question, okay? And Nicole and I are just going to be quiet for a little bit, for 5 minutes, and give you a chance to do that, and then we're going to talk about the answer. Okay, if you need any help, just shout. Off you go. Cool. Well done, Kanisile. How's everybody else doing? You guys are really quiet tonight. Is this one a bit tricky? Yeah, there is a little trick to it with Chepel. Cool, Thelma. Cool, Zianda. Well done. Kumo, you can in this case, yes. You don't need to, but in this case you can. So I'll show you two ways you can do it when we eventually go through the answer, Kumo. No problem, Kumo. No problem at all. This is one of those sorts of questions where you could do something to the left-hand side to make it look like the right-hand side, or you could work with the right-hand side separately. It wouldn't matter with this particular question. Okay, so I'm just going to wait one more minute. Cool, Mighty, well done. Okay, Mark, that's fine. As long as you've tried, we're going to go through it now, and then you can check that your working is okay. All right, so I'm going to get started on going through this. When you work with the left-hand side, what we would have done is we would have written left-hand side equals, and we would have used the tan identity to write tan A as sine A over cos A. So if you wrote tan A as sine A over cos A, you can give yourself 1 mark, because you would get a mark for every time you use an identity. Okay, so there would be 1 mark awarded over there. All right, now we are adding fractions. When we add fractions, we have to have the same denominator. So here, our lowest common denominator will be sine A cos A. And now I've got to do the same thing to the numerators. Okay, so I'm going to times that by sine A, and that by sine A, so that gives me sine squared A. And here, the fraction on the right, I've got to multiply the denominator by cos A and the numerator by cos A, and that gives me cos squared A over here. Now, we know that sine squared A plus cos squared A is 1. And that gives us 1 over sine A cos A. They could give you another mark here for writing sine squared A as cos squared A. And this is where the two options now vary in how you want to answer this question. So these are your two options. Either you multiply what you have by 2 over 2. How sneaky is that? And that gives you 2 over 2 sine A cos A. And of course, you guys know that 2 sine A cos A is sine 2A. Or your option is to work with the right-hand side. Okay, so if you had this as your other option, right-hand side equals 2 over 2 sine A cos A. 2 divided by 2 will leave you with 1 over sine A cos A. And then at this point over here, you could have established that left-hand side equaled right-hand side. Okay. is what allowed, Kulani? You mean where I multiplied by 2 over 2? Yeah, yes, Kulani, that's allowed. Why is it allowed though? Why am I allowed to do that? Because what am I really multiplying 1 over sine A cos A with if I multiply it by 2 over 2? Am I changing its value? So I'm not changing its value, Kulani. If I multiply something by a number over itself, then I'm multiplying it by 1. Okay, so that's why it is allowed. Okay, so here, 2 over 2 is actually multiplying by 1, and that's why it's okay. And actually this, in trig, comes up a lot where we have to multiply by 2 over 2. It's quite an important, yeah, it's quite an important thing. So do you remember last year when you were in grade 11, Kulani, you may have done rationalizing the denominator. All right, so if you have 2 over root 3, for example, in surds, you came along and you multiplied that by root 3 over root 3. Do you remember? So it's the same idea because you're multiplying by 1. So what I've highlighted in here in yellow is going to be 1. And then we would just do our normal thing with multiplying. Multiply top with top, bottom with bottom, and it's the same idea. Okay, so we can do that in trig, we can do it in Euclidean geometry, we can do it in all places. Okay, no, I think it's a good question. When do we use it? How do we know when the question requires us to? Well, in this situation over here, you knew that you needed to do it because you had a 2 at the top. Okay, so in order to get from this 1 over here, you would have to times by 2 to get the 2 at the top. And the other hint is that you've got sine A cos A at the bottom, which if you multiply sine A cos A by 2, that is sine 2A cos A. I'll try and think of some other situations, Kanisile, before the end of the trig course where I've seen this before, but it's mostly in identities. Okay, in this sort of thing over here. Okay, are there any other questions that you guys wanted to ask? No problem. Okay, all right, that's fine. Okay, so now, these are some of the questions that we didn't get to last week. But before we go ahead and work on these, I just wanted to have another conversation with you about cos 2a. So I'll give you an opportunity to work on those now, but a lot of grade 12 students struggle. So what I want to talk about is how do I know which cosine double angle identity to use? Okay, because remember, for cos 2a, you got 3 options. You got cos squared a minus sine squared a. You've got 2 cos squared a minus 1. And then your last option is 1 minus 2 sine squared a. So how we know which one to use, it depends on what cos 2a is combined with. Okay, so what you're going to do is you are going to look at the other terms. Come on, pen. So you're going to look at the other terms in the expression or identity or whatever it is. So now, for example, okay, just move that up a little bit. Let's say they gave you something like this. Now here again, we are required, this is an identity, and maybe orange isn't the best color, I don't know how easy that is to see. And let's say we are required to show that cos 2b plus cos b over sine 2b plus, sorry, that's actually minus sine b is equal to over sine b. Okay. Or consider this situation over here as well. So 1 minus cos So this is what I want to show you, all right? When I said to you, look at what the cos 2a comes with. So here you can see your cos 2a at the top. It comes with cos b. So when it comes with cos b, use 2 cos squared a minus 1 in the place of cos b. And then what happens is that that can then become a trinomial, which you could factorize, and I'll show you that now. So in other words, with the one that we have on the left-hand side, I would end up doing this. So I'm going to write 2 cos squared a plus cos b minus 1. Okay, this is now the left-hand side. And at the bottom, the only thing that I can do with sine 2b is write it as 2 sine a cos a, and from that I am subtracting sine b. Now, is everybody following what I've done in the numerator? I've switched some terms around. So cos 2b has been written as 2 cos squared a minus 1, but I haven't written 2 cos squared a minus 1 next to one another. I've put the cos b term in the middle because I want to make a trinomial. Does that make sense to everybody? Thumbs up. Oh, yes.
Could we maybe keep them all cos b? I think you have cos squared a plus cos b. I think we just mixed up the a's and b's a bit there.
Oh, sorry. Oh, they're all b's. Beg your pardon. Okay. Sorry. Thank you.
Thank you. Just to
no. Thank you. That was a b, and that's a b, and that's a b. There we go. Sorry, guys. Okay, so does it make sense what I am doing in the numerator? Is everybody happy?
Yes, ma'am.
You sure? Okay, all right. Okay, good stuff. So now we can go ahead and factorize the numerator. So in this case, this is going to be a trinomial. So this will be 2 cos b in one bracket, cos b in the other bracket. I need 1 and 1. Because I've got plus 1 in the middle, I'll make that one the plus and that one the minus. And now that's factorized nicely. And at the bottom, I'm going to take out sine b as a highest common factor. And that leaves me with, look here, 2 cos b minus 1. Works out beautifully, doesn't it? Okay, so now I've factorized. All my pluses and minuses are inside the brackets. Can you see how nicely combining cos 2b as 2 cos squared b minus 1 with cos b has given us this lovely trinomial in the numerator. And now we're able to factorize. And now the question is working beautifully, because we're going to cancel that guy with that guy over there. And look at that. Okay, haven't we got the right-hand side? We do. Okay, we've got cos b plus 1 all over sine b. Okay, and we're all happy, hopefully. Okay, you see what I'm getting at, how you know what to combine it with. All right, so now moving on, look at the one on the right-hand side. Okay, so this is a different identity altogether over here. And again, what I want you to do is look at what the cos 2x comes with. Okay, Kumo, you can use the quadrat. No, it wouldn't change anything. But the thing is that you're not solving. You're just trying to factorize. So using the quadratic formula here is, yeah, you're not working with the value of C or of B, you're just trying to factorize. Okay, all right, that answers that. Okay, so now, again, how do we know what to combine? Let's go and highlight it in yellow. How do we know what to combine this cos 2x with, so minus cos 2x in this case, all right? Again, look at what it comes with, all right? So in this case here, guys, it comes with sine x. So when it comes with sine x, most of the time, it's going to be useful for us to replace cos 2x as 1 minus 2 sine squared x. Okay, so let's go ahead and do that in this case and see what happens. All right, so again, we come along. Here's our left-hand side. It's equal to, now we've got to be super careful because in this question, we are taking cos 2x, which is a monomial, and we are replacing it with a binomial. We have to use brackets. Okay, or remember to change the signs. Okay, and there I go with the A again, and meanwhile we are working with X. Okay, can you see how also in this case, choosing 1 minus 2 sine squared x cancels out the 1. Okay, so very, very useful. Now at the bottom, we've got sine 2x minus cos x. Well, there's not really anything that we can do with that other than write 2 sine x cos x minus cos x. All right, let's simplify the numerator and see where we go. All right, so 1 minus 1 means the 1 is gone. And now we are left with positive 2 sine squared x minus sine x. All over 2 sine x cos x minus cos x. Okay, remember we can't cancel over plus and minus signs, so our next step is to factorize. At the top, we can only take out sine x, no trinomials here. So this gives us 2 sine x minus 1. At the bottom, we can only take out cos x. And again, this gives us 2 sine x minus 1. Lovely. All our pluses and minuses are inside brackets. We have factorized. So now it's okay for us to cancel a bracket at the top with a bracket at the bottom. And look how beautifully this all works out for us. We end up with sine x over cos x. And that's equal to tan x, our right-hand side. Okay. I unfortunately don't have an example that I want to show you. Yeah, thanks, Nicole. Yes. How are we feeling? Lovely. Okay. If you see, let's just change the color. If you see, how would you know when to use this one? So generally speaking, with the one that I just highlighted in yellow, if you see sine x cos x next to one another like that, then it's also sometimes a good idea to use cos squared a minus sine squared a, and then you can make a trinomial out of this as well. Okay, so yeah, just bear that in mind for that one. Okay, but generally it's what do you see with the cos 2x, and then we know which cosine double angle identity to use. Okay. All right. So I just wanted to bring that to your attention because I know that that's something that matrics do struggle with. Let's go back and go and have a look at these difficult questions over here. All right. Now, I definitely want to do I with you, but I'm now presenting you with some sort of difficult questions. So I'd like you to have a look at H, I, and J, and you are actually welcome to try all of them. What I'm hoping I'll be able to do is at least either 2A or 3A with you as an example, because we love those sorts of questions in Trig. All right, so yeah, Nicole and I are going to be quiet for a little bit, and you guys try those questions. If you want to maybe do 2 out of the 3, I think that that's fine. Okay, good luck. Off you go. Okay, Kumar, I'm just looking at what you've written here. You're getting 1 plus sine 2 theta. Can you see I'm going to deal with your question now? I'm looking here just at what Kumo. Okay, so Kumo, which question are we talking about? Are we talking about question H? Okay, and oh, you mean your final answer? You're getting 1 plus sine 2 theta instead of 1 plus sine 1 theta. Oh, okay. I think I understand what you mean now. All right. Okay. So can you see there? Oh, somebody else is saying me too. Okay, Tandalwetu, let's have a look. I don't think this is wrong. This comes out of the textbook I use every day, so I don't think this is incorrect. Let's have a look. All right, so we've got left-hand side, oranges. Not great, it's not good to see. Okay, left-hand side is, all right, now when we square a binomial, we've got to remember our middle term, right? So what we're doing here essentially is we've got cos theta over 2 plus sine theta over 2 multiplied by itself. So that's cos theta over 2 plus sine theta over 2. And now we're going to do FOIL. So first, cos squared theta over 2 plus outers. So that's sine theta over 2 cos theta over 2 plus inners, another sine theta over 2 cos theta over 2, and then lasts plus sine squared theta over 2. Now, we have 4 terms here, all right? The first term and the last term give us what? That's where the 1 comes from. Does that make sense? Okay, quite right, quite right. So that's where the 1 comes from. And now we've got plus 2 sine theta over 2 cos theta over 2. Right, so this next bit, let's just do this in a different color because it's something else. This bit over here is the sine double angle identity, isn't it? Right, now if we have 2 sine theta cos theta, that becomes, when we go back the other way, sorry, I wrote the wrong thing, that becomes sine 2 theta, doesn't it? Okay, so here we've got theta and theta, but here we've got 2 theta. So have a look at what we've got here on the left hand side. All right, if we want to write this as a sine double angle, what we could do is this. So we can write it as sine 2 of theta over 2. That's essentially what we're doing. I mean, this line that I've just written now is not necessary for us to write that, but it's showing you where the sine theta comes from. Okay, so the 2 at the top and the 2 at the bottom cancel out matrix. Okay, and that's where you end up with 1 plus sine theta, not 2 theta. Okay. That makes sense to everybody? It's a pleasure, Kanyisile. That's why I thought if I did everything, it would have, it'll make sense to you now. Okay. All right, guys, try I or J. There you go. Sorry, Butcher Paul. Yes, sorry, Zianda. I was also just thinking I need to go and grab this. Let me just drag it down here. There we go. Cool, well done. Nice, Mate. Yes, you can use a double angle after using a double angle. Definitely, definitely. Okay, so I'm just going to wait a couple more minutes and then we can go through I and J as well. Okay, so just to give us enough time to be able to wrap things up in case there are questions, what I'd like to do, if it's all right with you, is just go through I and J quickly so that you guys have this. I mean, of course, the other thing is that you can always come back to these at a later stage if you want to watch the video again and come and try them. Okay, so in question I, we have been given on the left-hand side sine 4 theta minus cos 2 theta. All right, so that means that in this case here, this sine 4 theta and this cos 4 theta are really functioning as the double angles. And expanding it too far in the beginning is just going to lead to problems. And I mean, we don't know this until we've actually experienced it, but this is what happens. All right. So what we're going to do is we're going to write sine 4 theta as 2 sine 2 theta cos 2 theta. I hope that makes sense to everybody. Minus sine 2 theta, which means that we can factorize the numerator by taking out sine 2 theta. At the bottom, okay, now this is what I was getting at previously. What do you see the cos double angle with? Okay, so can you see that in this situation over here, the cosine double angle comes with cos 2 theta. So this is where I was implying that the best thing for you to do is to write that cos 4 theta as 2 cos squared, in this case 2 theta minus 1. And then what we're going to do is we're going to pop that plus cos 2 theta in the middle. Okay, can you see how similar this is to what we were talking about previously? And now, guys, we can go ahead and factorize. We're going to take out sine 2 theta from the top. That leaves us with 2 cos 2 theta minus 1. At the bottom, we need to factorize 2 cos 2 theta, cos 2 theta. And again, we want that's identical. Now we can cancel something at the top with something at the bottom. And this leaves us with sine 2 theta, which is 2 sine theta cos theta. Now it works to expand further. And then at the bottom, the cos 2 theta plus 1, try and use something that cancels out the 1. So what's going to cancel out the 1 is going to be 2 cos squared theta minus 1. So let's do that. So 2 cos squared theta minus 1 plus 1. There's our 1 gone. All right, so now we can cancel the 2 and the 2. Remember, we're not cancelling over plus and minus signs because 1 plus 1 is 0. And cos theta will go into itself once, and it's going to go into cos squared theta, cos theta number of times. So that's going to leave us with sine theta over cos theta, which is tan theta. Okay, and that's how left-hand side equals right-hand side. How did that go? How do you feel? You feel good, happy, making sense? Questions? Okay, cool. Oh, I'm glad. Okay, cool. That's good. That's cool. All right. So that's why I'm also trying to give you questions that tie into the stuff that I've told you so that you can see, you know, when I said to you, use this or that or whatever it is, you know that what I'm referring to. Okay, let's do J quickly before, I almost said before the bell goes. I suppose it is a proverbial bell, but anyway. All right, so question J, and I think with this question, not I think, I know, okay-ish. Okay, you know what, Emitle? I promise you, there is no secret formula, there's no magic potion. It's not a case of some people are really good at maths and they know everything and we can't know what they do. It's just practice. Okay, everything becomes easier with experience. Like when you learn how to drive a car, you know, you start off and you stall the car and you don't know how much gas to give and how to take your foot off the clutch at the same time. And, you know, you drive a car enough times, you don't even think about it. It's the same thing with this. Okay, so just practice, practice, practice. All right, so left-hand side equals sine 4 theta matrix. Okay, so that gives us 2 sine 2 theta cos 2 theta, doesn't it? Which I think we can leave that like that. You just leave it there for 2 seconds. Okay, now I want to go to the right-hand side. I'm just going to leave some space in case I need to write a little bit further. And on the right-hand side, I've got 4 sine theta cos theta minus 8 sine cubed theta cos theta. Okay, so now what can I take out as a highest common factor on the right-hand side? Well, I can certainly take out 4, and I can take out sine theta cos theta, can't I? Okay, so what does that leave me with? It leaves me with 1 minus 2 sine theta. Let me just double check that that's correct. So 4 sine theta can jump 1, 4 times 2 is 2, sine squared. Okay, so now I'm just going to go back here. 2 sine 2 theta can be written as 2 times 2 sine theta cos theta. And I can rewrite cos 2 theta as 1 minus 2 sine squared theta. Sorry, I'm squashing this in a little bit here. But there we go. There it is. So there's our 4 sine theta cos theta multiplied by 1 minus 2 sine squared theta. Okay, and therefore left-hand side equals right-hand side. Is that okay? Does that make sense? Cool. Oh, good, Cassandra. That's great. Thanks, Kanyisile. Good job. Cool, Loroto. Lovely. Lovely, lovely, lovely. Cool, Jamie. Yeah, Tatsu, these are hard, hey? It's not easy. I understand. Nicole, do we need to do the poll tonight?
Yes, I think we should do the poll to see how everyone's doing.
Okay, all right. Well, then in that case, I'll stop there. And then you guys can answer the poll. Thank you, Matrix.